I've just been told there's an online test on rare skills for Solidity developers. I thought it might be cool to try it out and see what happens. I haven't done it yet. I'm gonna do it live. Hopefully we do well. So yeah, let's just do it. This is the page. I have already, I think you have to go here, test yourself, go to take the test, something shows up, you put your email and everything. You will get to this part. It says that we have 45 seconds to answer each question. And we are not penalized for guessing, so if I don't know something, I will just drop a coin and see what happens. There might not be correct answers in checkbox questions, so that means that there probably are like different types of questions and blah blah blah. Supplying your email, yes. Okay, how experienced am I with Solidity? I understand it very thoroughly. Sometimes I'm very experienced. I built a token, I've completed, I don't know, I'm very experienced, let's say. Okay, so we have 45 seconds each question. I'm getting nervous with this. I don't know how many questions we will have. I read somewhere that average developers only get like 30% or 40% score. I don't know, I'm getting nervous. Hopefully I do well. After 3 years of auditing, I should know something. If I don't, anyway, let's see. Start test. Okay, question 1, we have 1 minute. What does require equal message sender do? It will only accept transactions from smart contracts. It will accept transactions from smart contracts only if it's gonna, it will block transactions from regular wallets probably. It doesn't do anything. No, this is not deprecated. I think it will only accept transactions from regular wallets. Depending on what wallets means, right? This is none. It will only accept transactions from smart contracts. No, it will accept transactions from smart contracts. It should be this one. Okay, some Solidity code. Roll the dice. You only have 1 ether plus a, okay, you win. Can you win these games and get 2 ether? Require message value equal 1 ether if blah 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 equal 3. The contract pays the caller 2 ether, so the contract must at least have 2 ether. If you have 1 ether 6, so you probably shouldn't pay. If the contract doesn't have 1 ether in it, you will lose the 1 ether. No, if it doesn't have 1 ether, it should fail, right? Even if you get the correct number, let's say you get the correct number, it doesn't have 1 ether in it, so the transaction should fail. You can rely, yeah, probably this is this one, this like random stuff on the blockchain never works. Let's say this one. So question number 3, why does the gas cost of a public external variable change when the name of the function changes? The name of function doesn't affect the gas cost. Yeah, okay, the gas cost might change. Yeah, I mean, if you have more arguments, probably. The longer the function name, the more space. No, the function might have more leading zeros. Yes, so it means that Calldata will be cheaper. Its position in the bytecode relation. No, I don't think it changes, right? The function doesn't affect the gas cost. Yeah, this is true, but the arguments to the function change, the gas cost might change. Yes, okay, how can a smart contract change its bytecode? Interesting. Okay, a proxy contract can change its bytecode. Number 2, if the contract loads external bytecode, it can be deployed. Yes, this one. Can point to an arbitrary new contract. Although smart contract is technically mutable, their bytecode does change when storage value. No, blah blah. After the contract has already been constructed, no, I think it should be this one, right? If this were like checkbox, I would be more worried. No, but no, okay, it's this one. Okay, let's go. Function foo, 2 parameters, external. What is the minimum valid Calldata size for this function? Oh, I hate having coding. So we have 4 bytes for the function identifier. Then we will have 32 bytes to encode the length, 32 bytes to encode the other length, which should be 0 and 0, but these are dynamic parameters. So if I'm not mistaken, I want to look up the Solidity documentation, but it should be, so it's 32, it's 64 and 64, it's 128, 132. So you have 128 from the parameters and 4 from the identifier, so probably 132. Okay, let's go. What is wrong with this code? First thing I see is first dividing then multiplying. That's usually a bad thing. Total value might not be divisible by contributors.length. Yeah, could be the case. Arithmetic overflow, no, I don't think so. Nothing is wrong. And the value to send might be 0 even if total value is not. Yeah, total value might not be 0 and value to send might be 0. Yeah, I think this is it. Okay. What is true about private, internal, external, and public functions? Public functions can be called by other smart contracts. Yes. Some of these are related to inheritance. Yes. External functions can only be called by smart contracts. False. All of these except external could be used to describe variables in addition to functions. No. There is no such thing as an internal function. I don't like the wording of some of the answers, like particularly this one. What is a protected function? I have no idea about that. I would say the first two, right? So public functions can be called by other smart contracts, and some of these are related to inheritance, right? So internal functions and blah blah. Okay, let's go. Question number 8. What is the difference between these two functions? So they are pretty similar. Okay, what's changed is the name A and B, and this required is the second instruction here. This is the first. So there might be unexpected behavior if x equals 0. Unexpected behavior, what does it mean? If x is greater than 10, the values won't change in either function. That's true, because it should revert. If x is greater than 10, the values won't change in a function. No, it will revert. Function B will potentially save the user gas compared to unexpected behavior. I don't know, man. What is true about block.timestamp? The number of milliseconds in general, no, it doesn't have to do with time zones. The timestamp is determined by the miner or validator. I think to some extent it is. At least that was true with miners. I don't know what's going on today with validators. And the number of seconds, right? So timestamps are in seconds. Yep, okay, let's go. What is true about ERC 721? Both mint and safe mint are potentially reentrant. Safe mint is potentially reentrant. Okay, this should be right. So neither mint nor safe mint are potentially reentrant. Blah, blah. Mint is potentially okay. No, it should be this one. I mean, this is weird because I don't think these functions are actually defined in the ERC 721 standard. So I don't know exactly what the implementation they are referring to. But if it is the one from Open Zeppelin contracts, probably this is it, right? So safe mint is the one that is potentially reentrant because you have an external call at the end of the mint to the receiver contract, but mint shouldn't have that. I don't know. Okay, let's go. Which of the following is true and about is true about generating random numbers from Ethereum? Block hash is not reliable as long as randomness computable scheme can produce safe randomness under certain assumptions. I don't know, this is like very generic. Combining the block hash with a random layer makes it safer. I don't think so. Yeah, I wouldn't say it's unreliable because of this. So you can predict it at the end of the day. So, and the miner can also manipulate it. And what about this one? So a commit-reveal scheme can produce safe randomness. I have no idea. Let's do this. What is the smallest units of ether? Wait. Which of the following variable types can be stored in memory? In memory. So you can store an address on memory. Yes. A struct. Yes. A uint, a boolean. The output of a hash. Yeah, the output, I mean, you would have, if you hash something, you can store that in memory. An array you can store in memory. Is it everything? Shit. I'd say so. I mean, is there a catch here? I'm not reading something. Variable types can be stored in memory. Whatever. What is the difference between transfer and transferFrom in ERC20? TransferFrom could be reentrant according to what? TransferFrom could be reentrant. TransferFrom can be used by an approved spender on behalf of another. Yes. Can only be used by the token owner. No. Transfer can be used by an transfer can be used by an approved spender. Nope. According to ERC20 standard. I don't think the ERC20 standard says anything about that, right? I started out everything. Okay, let's go. What is true about payable and non-payable functions? Payable functions are more gas efficient, I would say so. I think that's because the Solidity compiler for non-payable functions, it puts like additional checks to revert if you're sending Ether. So payable functions, as as long as I remember, are more gas efficient. Only payable functions can be viewed. Yeah? No, I don't think that you can have a payable view. No, that's not true. Only payable functions can have self-destruct functionality. I don't know. No, I don't think so. Yep. Okay, let's go. When a smart contract is verified in Etherscan, which of the following is true? Okay, the source code is stored on the blockchain? No, it's not. At least one person has used it? No. Only the entity that deploys the smart contract? No. The smart contract bytecode of the compiler output matches the smart contract bytecode on the blockchain? Yes. If a contract is verified on Etherscan, then you can trust. You wish. Okay. What Solidity version introduced arithmetic underflow and overflow protection? Was it 0.7? No, I think it was 0.8, right? I'm pretty sure it was 0.8. Yeah, should be 0.8. Shit, what if it's 0.7? No, should be 0.8 and no, and you should... No, yeah, okay. Yeah, okay, this one. What is true about virtual functions? Virtual functions must be... Okay, probably it's this one. So perhaps you can have a contract that is not abstract, but that has a virtual function, must be overridden by a child contract. I think they should. Must be. Okay, I have to check this one. Okay, probably this one. What is the difference between a view and a pure function in Solidity? Pure functions cannot make calls to arbitrary smart contracts. Pure functions cannot return any data, but no. A pure function cannot have any side effects, but a view function can. No. Pure functions cannot access blockchain state, but view functions can. True. Pure functions will revert if they access blockchain state. I mean, the thing won't even compile, right? You can mark it pure and it accesses state. Or perhaps you can access state in assembly, and I don't think the Solidity compiler will. Cannot make arbitrary calls. I don't think you can make a call. Okay, I don't know. I'm very unsure about that. So, what happens if a program enters an infinite loop on Ethereum? The transaction will revert. Yeah, probably, because it will run out of gas. The compiler is not allowed to. The Ethereum client will warn the user. No, I don't think so. Probably it's this one. The validator will reject the transaction after seeing it hasn't terminated past a certain time. I don't know if the validators have that embedded. I don't think so, right? And this is not, so the transaction will revert. I mean, the idea is that a gas exists so that you cannot actually enter an infinite loop. So I don't like the way the question is phrased. I would say the transaction will revert. Okay, as of 2022, what is the maximum smart contract size? I think it's 24 kilobytes. What is the layout of Y in memory right after line? Oh shit. So we have an array defined here, 1, 2, 3, 4, uint 8, and this function is, okay, it's copying X into Y is into memory. Should be this one, right? Wait, but shouldn't you also be storing the length of the array in memory? And I don't see that in any option. Shit, what's going on? What am I missing? I'm pretty sure it's this one, right? So each element gets stored in a word on memory. You don't pack them like this, but okay, shit. What is Ethereum's primary hash function? I think this one. So which of the following is true if I don't like 51% attacks on the network? So now in proof of stake, perhaps things change. I don't know. The nodes can censor you. Yes, I would say so. The nodes can steal your ether. They can fork the protocol, but only if and only if they maintain more. They can conduct a denial of service. I would say so, yes. I have a hard time thinking about 51% attacks because I always think that as soon as we see that on Ethereum, like we would solve it at this social coordination layer. I don't know. Okay, whatever. I don't feel I'm doing well. So what is the difference in the call data between my function, Yeah. Okay, same function, different arguments. It depends on which version of what the fuck. The call data for my function will be smaller? No, I don't think so. It will depend on the number x holds my function can create larger call data. I think you always have like the same size of the call data, right? It's then a thing of Solidity that it checks. It depends on which Ethereum hardware. I don't think there's difference, man. So it's the same name, and I would say the call data would be the same length, but Solidity will have embedded some bytecode to check the size of the parameter. So I would say there's no difference. I don't like these quizzes, man. Okay, question 26. What is true about transferFrom and safe transferFrom in ERC 721? Safe transferFrom allows you to transfer. Nope. Yes, okay, it should be this one. TransferFrom might be reentrant, but safe transferFrom is not reentrant. No, I think it is. Only this one? 15 seconds. TransferFrom checks if everything. Okay, shit, let's go. Question 27. What limits the block size in Ethereum as of 2022? There cannot be. No, I don't think we have a limit in the number of transactions. I don't think we have a limit. I think the limit is on the gas side, so it's probably this, and this. But as far as I remember, the block size is limiting gas, but it's also dynamic in some sense, so it changes depending on the base fee and EIP 1559. But I think it's 30 million. I think tops is 30 million. I think it's 30 million. 70% sure. I don't know. Okay, what is wrong with this code? I'm an auditor. I should know this. And what could be improved? Oh, many things. The code is reentrant thing. I don't know. It's not reentrant because we are executing a call on tx.origin, and tx.origin shouldn't be a call. The variable balance should have visibility. Yeah, I mean, should. Withdraw should be payable. I don't think so. Can be a security vulnerability. Yeah, there are attack vectors using tx.origin. Withdraw will fail unless the code is changed. Oh, this is a good one. Can you execute? Yeah, I think it's a low level call, right? So it won't fail. Okay. What does Selfdestruct do? Sends all the ether to the address specified in the first argument. Yes. Will revert if the recipient address doesn't. No. Sends all the ether in a contract to the address initiated. No. Removes a smart contract bytecode and store. Yes. After transaction will save all function calls. No, I mean, it will be just an empty account. You can, I don't know, call it and transfer ether. No, I don't think all functions will revert. We have some time. Let's think about if I'm missing anything. I don't like quizzes, man. What does Delegatecall do? It's how smart contracts forward goes to our contracts. No, it executes a function that might be a smart contract in the context of the current smart contract. Yes, it should be that one, right? So it's how smart contract listen. That's a good one. It is used to defer function execution. No, should be this one. Oh, Solidity code again. What is the highest value the free memory pointer can achieve? Oh man, so the free memory pointer starts at value 80, so should be bigger than that if anything happens. So we have a function. The question is, do any of these operations at the end of the day touch memory? Right? Do you require touching and manipulating memory to execute any of these? Closed, that's an S-load. This is just stack stuff, and probably this is also an S-load. You have an S-store here, assuming this thing is on state. I don't think you touch memory, do you? There is no limit. Okay, go. Shit, which of the following is most costly in terms of gas? Reading storage variables, right? So always touching storage is quite expensive. Not in memory, not message sender, no immutable variables, reading Calldata, that's actually quite cheap. So reading storage variables should be the most costly operation in terms of gas of these ones. 33. So we have 3 contracts, inheritance stuff, boom, self-destruct. Okay, contract C is deployed. Yes, so contract C is B is A. When boom is called, which of the following is true? There are 3 contracts. No, there are 3 contracts defined, but you only deploy 1, right? Okay, there is 1 contract. C is destroyed. Boom cannot be called because B, no. There are 3 contracts. No, there is 3, no. Sometimes I think that I'm missing something, you know, like it should be this one. Okay, let's go. Question 34 out of 40. EAP 1967 proxy storage slots specify which storage slots. I think it's the implementation address and the admin address. That's tricky, man. I don't remember. I think 1967 is the one where you specify like the hash of some stuff and define the admin and then also the implementation. Yes, okay, let's go. What is the difference between create and create2? Okay, create2 takes a sole parameter. Do you think can predict The address in create 2? No, you can predict create. The user has more control over the address in create compared to create 2? I don't think so. Created for creating one smart contract? No. Yeah, I'm taking the last one. It's tricky to say has more control, it's quite vague, but in create 2 you just kind of tweak the salt. Compared to create 2, I'd say you are more in control of the address, right? What am I missing? Am I missing anything? Okay, should be it. Which of the following are valid uint sizes? 8, 16, and 32. Okay. What does a static call opcode do? It's deprecated. It's funny. Should be this one. It makes a function call and reverts if a state change occurs. Yes. How is an Ethereum address created? The hash of the public key, but it's not the entire hash. Okay, this one. An Ethereum address is the last 20 bytes of the hash of the public key. Let's just make sure. On the other ones, an Ethereum address is a random string. No, it's public key. Yeah, let's do this one. 39. Oh, I'm getting so close. I'm getting nervous. I don't know. See the smart contract below. Where is the storage slot of Y? Okay, Solidity, this is 228, so Solidity should be packing this, I think so. So the storage slot of Y should be 0, right? Because you're putting that together with X. And in slot 1 you have Z, you don't hash nothing because it's just simple number, so 0. Yes, okay, let's go. Last question. The DAO hack in 2016 that resulted in the split of Ethereum Classic was hacked with what kind of exploit? I think it was reentrancy, right? Compromise for keys? No, that's 2022. Arithmetic underflow, insufficient access controls, arithmetic overflow. I think it was a reentrancy. About to submit the last question. Hopefully, I'm quite confident above 50%. What do you say? Yeah, I should be getting above 50. I had some doubts in some questions, 10 seconds, but I think I did quite well. Huh. Okay, submitting. Test ended. Whoa, okay, not bad. 77. Okay, we missed 9. Not too bad. Where do I see the answers? Can I see the answers? Oh man, correct answers have been hidden by the test owner. Ownership. How do I learn, man? Come on, rare skills. How do I learn? Shit. And it would be nice to also like have I wouldn't say a leaderboard, but I don't know, some statistics. How I did with others. I think I did well. Like 40 questions, very limited in time, 1 minute per questions. I think I got 31 right. So that's a lot. Better than I expected, honestly. I really want to see what did I get wrong. Shit, I wish I could do that. Anyway, 77.5. It's not only 77. I think I did quite well. I got a little bit nervous. Like on the middle of the test, I was doing better, and I got nervous kind of at the beginning and at the end. Perhaps I got wrong the one about the 51% attack. I should read on that. The ones about like ERC 721s, I'm pretty sure I also got that right. I wish I remember them all. Okay, that's it. 77.5. Nice.